Yes, Earth. I guess I should take off the Zoom since it's a PowerPoint.
Very nice.
Thank you.
That was
I
a very
tried.
nice
Alright, it is the only planet, oh, it has some words. The only planet known to sustain life for 3 main reasons. What are they?
Water. Oxygen.
Temperature.
Let's raise our hand.
Water and carbon.
Water is kind of right.
The magnetic field.
Somewhat, yes.
Distance from the sun.
There's my first one. And they're not all together wrong. Just when you have a PowerPoint, you gotta go in some order. Presence of liquid water. So water is not necessarily the answer. It's the state of that we are able to find water here. Layer of air, as he mentioned, of our atmosphere. And then our distance from the sun. You know that one of my students want, and I'm gonna, oh no. All right, so without sun, obviously there's no life on Earth. This question probably will pop up on the AP exam in some way. Sun is the start of all energy, the main source of energy. It is 100% of our energy on Earth that's then transformed into all these other forms of energy. It's the driving force of a lot of cycles, so it's critical component. So here's the story, the most recognized story, right? Not necessarily the Catholic story. This is the science story. 4.5 billion years ago, you have to know that number. I promise you, I say this and you don't believe me, that's a question on the AP exam. How old is Earth? 4.5 billion years ago, Earth looked like this. What does that look like? Look at it. What's happening? It looks like it's on fire.
Meteor shower.
Meteor showers, yeah, and I have this great video I'm gonna show you. It was like a giant, and there's probably some typos here. I never fix them for some reason. Boiling soup of molten rock. So it was almost like Earth was a volcanic eruption. Now the video that I show you goes one step further than the 4.5 billion years. It talks about the solar system and how it led to Earth. So it's a really good video. It's long though, so I'll see what parts I can show you.
Why did they think it was like a red hot, rolling, boiling sea of molten rock?
Because there was some shower of meteors in the solar system that created this like heat energy, because you know one of the laws in science is what? Conservation of energy, or not conservation, but the law of energy, conservation of matter. Those are 2 laws. So something started this.
The law of thermodynamics.
Correct? That's our unit 3. All right, so then if Earth was this hot molten rock, what do you think can happen? No life yet. So what's going to happen? It's going to cool down. And if it cools down, it's going to look like that. So what forms?
A solid.
What? Rock, which is what of Earth? The crust. So Earth cooled and our crust formed. One of the layers of Earth that we're going to talk about.
How did like land and come together in space? Like how did it not just like fall off continuously? Was there already a planet that this meteor shower landed on?
It kind of like, you'll see in the video. And you know what? The how the planet formed is we're starting it from where Earth started, okay? Not like solar system, which is for me really hard to I have a hard time accepting that we're here floating around in this. I know it's true, but it's hard for me to, you know what I'm saying? Put myself. All right, so Earth cooled, our crust formed. And then what happened? Volcanic reactions continued, because even though the crust cooled, that heat doesn't go away. So it stayed underneath, constantly trying to pour out, and volcanic eruptions led to what?
Vapor.
Good, vapor. I rarely get that. Vapor in the atmosphere. What else do you see there in that picture? Fire, clouds. So what's gonna form?
Yeah.
The atmosphere. Volcanic eruptions emitted, and it was mainly consisting of carbon dioxide and water vapor. What else comes out of volcanic eruptions?
Sulfur.
Sulfur, good. So all these things you have to know. Sulfur, the answers are gonna be sulfur, water, carbon dioxide. Methane is there, nitrous oxide is there, but the key components are sulfur, water, carbon dioxide. So they formed our atmosphere. Make sure you write that.
What was it? Water.
Volcanic eruptions mainly consisting of carbon dioxide and water vapor, led to the atmosphere. Now there's our atmosphere. Now water vapor is all over our atmosphere. And we know that vapor condenses, and then what? And then it rained, and it rained, and it rained, and then
Wait, but how did that
the
not-
oceans formed.
How did that not vaporize from the lava and stuff that was already on the ground? Fire. They just go through like endless cycles until all the molten hot stuff on the surface
Somehow cooled, something had to have happened.
and then
So
it's just
supposedly, according to what we know, what do you think comes next?
like
Life. Well, even more than life, you're gonna have some land formation because the volcanic eruptions continue. It says the oceans formed and all of Earth was like an ocean, which we know how much of Earth is water still today. 70%. So you see the big chunk of Earth is approximately 70%. Then 1 billion years later, life begins. What kind of life? Bacterial or microscopic life. We're gonna say prokaryotes are the first organisms. And then after prokaryotes, eukaryotes, and so on and so on and so on. We know this from the evolution of life, right? Or fossils. Look, evolution. Who believes in evolution? Now, who believes that evolution is the explanation